Welcome to VMworld 2021. My name's Peter Kieran, and I'm alongside Bob Bauer and Jose Manzanique, and we're going to bring you the guided workshop for the Hands-on Lab 2213, which is vSphere with Tanzu. The agenda for today is we're going to give you a brief introduction to the lab captains. We're going to talk about how we constructed the lab, get into the lab experience itself, and then Jose Manzanique is going to walk you through some of the VMware with vSphere with Tanzu lab. Bob Bauer is a Kubernetes staff solution engineer based in Minneapolis, Minnesota. Jose Manzanique is a Kubernetes senior specialist engineer based in Madrid, Spain. And I'm Peter Kieran. I'm based in Calgary, Alberta, Canada, and I'm a staff cloud platform architect. We're the three developers of this particular lab. And in this particular lab, we created a vPod that basically gets deployed over and over and over again. And to do that, it takes about a 3-month development process for us to build, design, build, and develop the lab with all of the associated instructions. And in this particular lab, we iterated from last year's version of the vSphere with Tanzu by integrating NSX Advanced Load Balancer, or AVI Load Balancer, alongside with the newest version of Tanzu with vSphere. What this will do, it'll give you a fully integrated Kubernetes solution that you can manage with vSphere and vCenter. In this particular lab, we've got over 1 terabyte of storage deployed, 380 gigs of RAM, and over 120 vCPUs based on vSAN-backed storage. And what's interesting about a vPod is it's something that we can deploy over and over again. So if you imagine your vSphere environment, imagine it shutting it down and restarting it every time you wanted to use it. That's essentially what we do with a vPod. So it does take a little bit of development time for us to get all of these startup procedures so that we can do this on a repeatable basis. Bob, I'll turn it over to you and you can talk about the actual lab design and construction from a conceptual basis.
Thanks, Peter. So when we look at the HOL public cloud infrastructure, it's running on, I think, up to 5 clouds, Peter, if that's correct.
Yeah, there's 5 clouds this year.
Yeah, great. So there's a lot of infrastructure behind it, but then we use the vCloud Director app to create a replica of a cluster in your data center. So we've got the layer 1 VMs, which are running on the vCloud infrastructure, the primary virtualization layer. And that's where you have things like the ESXi hosts, the vCenter, and our router. And then this year, as Peter mentioned, we're using NSX Advanced Load Balancer, also known as AVI. And so in the layer 1 VMs, we have the AVI controller, which is the control plane for the NSX Advanced Load Balancer solution. And then we have a set of VMs that are running as layer 2 VMs, which means they're actually running on the nested cluster that we've created. And this is where the supervisor cluster VMs, which we'll talk about in a moment, run, as well as the service engines for AVI that actually provide the layer 4 load balancing. So AVI includes layer 4 load balancing for the Kubernetes APIs for any clusters you create, as well as a supervisor cluster. And it also provides layer 4 load balancing for applications. What we do is basically when you enable Tanzu Kubernetes Grid service on vSphere 7, these supervisor cluster VMs get deployed as part of that enablement. And as part of module 1, we have some interactive simulations, or iSims, which actually go through the enablement process. How would you stand up the AVI solution? And then how would you enable Tanzu Kubernetes Grid on vSphere 7? So when you get to module 1, you'll have an opportunity to watch those, which steps you through the install and enablement process. We don't do that in the lab because it takes a fair amount of time and resources. And so we do that for you ahead of time.
Bob, one question I've got is, in previous versions of the lab, we've used NSX load balancer and we've used the HA proxy. Is that still supported?
Thanks, Peter. That's a great question. Yeah, we still do support both NSX to handle the whole networking functionality, not only the virtual networking for the nodes and all of the pods that get deployed, but also we do support HA proxy like we did last year. So this year, when you go through that iSIM, you'll see there's an opportunity. If you already have NSX deployed and enabled, you can choose to use NSXT instead of NSX Advanced Load Balancer or HA Proxy. And you could also select those other two options as well. So all three are supported this year. Peter, thank you.
Thanks very much. So now we're going to move on to the instructor guided lab, and Jose is going to be walking through module 3 will be the focus, but we're going to touch on a few concepts from module 2 as well. So when we work with the Tanzu Kubernetes grid inside vSphere, we're going to introduce you to namespaces, to the TKG clusters. We're going to build and deploy an application, and we're also going to give you a brief introduction to the VM service in this particular guided workshop. You can go into more depth if you take the full lab yourself. You can, by all means, spend more time working with a lot of the applications that we have inside the lab and building and deploying those alongside with the VM service as well. At this point in time, I'm going to turn it over and we'll have Jose take over and he'll start sharing.
Thank you, Peter. So let me share my screen. And this is the first thing that you'll see once you log in to the HOL. So first of all, I recommend extending the time as much as you can to ensure that you'll have enough time. And you also have the lab manual over here. I definitely recommend maximizing your lab console. And if you have a second screen, you can detach this lab manual in order to get even more space. So in this guided workshop, I'm not going to be using the lab manual, but everything that I'm going to do and all the commands that I'm going to type, you can find it in your lab manual. And you can also benefit from this send text feature. So you won't really need to type anything. You just need to copy and paste, and everything will be working for you. So the first thing that you'll need to do is you'll need to go into Google Chrome, and once you open Google Chrome, it will redirect you to the vCenter. So just use the credentials that have already been saved and hit login. And the first thing that you'll notice in this environment is this resource pool that says namespaces and these two new cool icons that show us demo app 01 and TKG cluster 01. This means that this vSphere cluster has already been enabled as a supervisor cluster. This means that having a supervisor cluster will provide the self-service capabilities for developers, and they'll be able to self-provision Tanzu Kubernetes cluster and VMs using the VM service. So we can verify that this is indeed the case by going into menu and workload management. And under clusters, we can see our vSphere cluster that is running and is working as well as a supervisor cluster. And we can find the IP address for the control plane. And if we go here to namespaces, you can see that we already have two namespaces created. So you can use the existing demo app 01 namespace, or you can create another one. So in this case, I'm not going to create a new namespace, and I'm just going to go over the demo app 01. So in this demo app 01, you can see that this namespace is running, and you can think of a namespace as a folder or as a project where developers will be working and where they will have self-service capabilities for creating new Tanzu Kubernetes clusters, which are called the workload clusters, creating new virtual machines, and so on. So as a VI admin, you will be creating these new namespaces, and you will be configuring the permissions. So this, as a VI admin, you'll control what developers can do inside of this namespace. You can control if developers are able to just read and just to be able to see resources, or if they are also allowed to create new resources. You will also be able to control the storage, and this is where the great integration with vSAN kicks in. So with the storage policy, this means that you will be able to use your existing storage policies and to consume those into Kubernetes as storage classes. If you're using vSAN, this means that you can enable all these great vSAN features, for example, deduplication, storage encryption at rest, different kinds of redundancy, and all of this will be entirely transparent to developers. So all these policies that you have defined as a vSphere administrator will be applied seamlessly into the Kubernetes environment. And this can also be a great tool. For example, if you have multiple storage layers, you have one crazy fast and great storage, you can dedicate that storage, that expensive storage, to production environment. While if you have slower magnetic storage, you can dedicate that to the non-critical workloads or development namespaces. So in this case, I'm just going to use the Kubernetes default storage policy, which is provided by vSun. And now that we have defined the storage, we can also configure further limits on CPU and memory that can be consumed inside this namespace. So if we hit here, edit limits, we can control the CPU limits at the vSphere layer. And if we have multiple storage policies or storage classes inside this namespace, we can also define storage limits for each of these storage classes. So you can see that we have one Tanzu Kubernetes Grid cluster created, and we can check that out. And we can see here that under this namespace, there's one TKG cluster created that has one master and 3 workers. So the first thing that you should do is you should log into your Linux 01 jump host, which I'm going to close this window and I'm going to do it again. So if you go into PuTTY, you'll see one saved session, and just double click it and log in as the root user, and you'll get logged in automatically. So the next thing that you need to do is you need to log into the supervisor cluster in order to start creating resources. So we can go to, if we use the kubectl vSphere login command, you can see that we are now logging in to the control plane endpoint that we were previously seeing under workload management, and we are logging as the administrator at vSphere.local. So this is going to ask for my administrator at vSphere.local password, which is in your lab manual. And you can see that this message is telling us that we have been authorized to use the following contexts, which are the vSphere namespaces. And we can change context to this kubectl, to this demoapp01 namespace by using this command. So I'm going to use it, and I'm going to switch to the demoapp01 namespace. So if I type kubectl get tkc, you will be able to see that I have my Tanzu Kubernetes cluster, this TKG cluster 01 right here. And I can, for example, I can scale the cluster, I can update the cluster to a newer Kubernetes version, but this supervisor cluster will be used just to provision Tanzu Kubernetes clusters and to provision the to manage the lifecycle of VMs with a VM service. But I'm not going to be running the production workloads directly into this supervisor cluster. I will be using this Tanzu Kubernetes Grid cluster, which will be my workload cluster. In order to start working with this TKG cluster 01, I have to use a very similar command to this one that I was just using. And I can use this command, which is very similar, but you'll notice that we have this dash Tanzu Kubernetes cluster flag and this dash Tanzu Kubernetes cluster namespace flag. So I'll use this command, and it will ask for my password again. And I will be able now to log in into this TKG cluster 01 namespace. So I will use a very similar command. So we will use TKG cluster 1 instead of demoapp01. And if I type a kubectl get nodes, you'll notice that I can now see all these VMs, these control plane VMs, and the 3 worker nodes. So now that I'm logged in here, I can start deploying some applications. So under the labs folder, so just move into the labs folder, you'll see some applications. We have the Nginx application, which is a basic web server. We have the Hello Kubernetes. we have the guestbook, and the Acme Fitness. So for the purpose of this guided workshop, I just go over a very simple application, which will be the Hello Kubernetes application. But I definitely recommend trying the Acme Fitness application, because it's a microservices based application, and it will showcase how the different pods and the different containers interact with each other, and very small components and very small microservices can make up a really complex application, which is one of the key features of Kubernetes. So in order to deploy the Hello Kubernetes application, I will move into the Hello Kubernetes folder, and we can see here this hello kubernetes.yaml file. So this YAML file, this will define our deployment, and these are the files that Kubernetes uses in order to understand our application and the desired state of what we are trying to deploy. So you can see here that I have one deployment called Hello Kubernetes with 3 replicas. This will mean that Kubernetes is going to deploy 3 pods for this application, for high availability and for load balancing capabilities. So I'm deploying 3 replicas of this Hello Kubernetes Docker image, which is stored in our Harbor image registry. So there's also another module on how to create a Docker image and how to upload that Docker image into Harbor, and I definitely recommend going over that that module because it will show the full end-to-end process from having the code of the application, packaging that code into a Docker container and into a Docker image, and then deploying that application into Kubernetes. So I'm just going to deploy 3 instances of this Hello Kubernetes container image, and I'm going to be exposing the application using this service with a type load balancer. This means that once we create this load balancer inside Kubernetes, the ABI networks or NSX Advanced Load Balancer will provision the load balancer for us and will make our application accessible from the outside. So in order to deploy this YAML manifesto, we will type kubectl apply-f hello kubernetes.yaml, and we can see here this deployment and this service that have been created. So we can check if the application is running by typing a kubectl get pods, and we can see the 3 containers for our Hello Kubernetes application running. Please note that you might not see in your environment this Nginx application, and that's totally normal. You just need to see the 3 pods of this Hello Kubernetes application in 1 out of 1 running state. This may take a few seconds or a few minutes until you see all the 3 pods as running, but that's totally normal. And then we can check the endpoint for our application by typing kubectl get service. You'll notice that I have this Hello Kubernetes endpoint, and it's telling me that my external IP is 192.168.130.116. And also, as before, you may not see this Nginx service right here, but just verify that you are getting an IP in this 192.168.130.0/24 range. And also, please notice that the IP might be different in your case. So with this IP address, we should be able to go back to Chrome and to access our application. So I'm going to try to access to our application, and this will take a few seconds, but we can already see the title. We can see that it's now loading. Take a few seconds. And we can see our hello world. So this means that our application is now running inside of the cluster, and our application is now accessible, and it's being made externally accessible through the ABI networks service engines, which Bob covered before. So I definitely recommend testing some more advanced applications, such as, for example, the Acme Fitness. And you can also check all the objects and everything in the cluster in a more graphical way by going into Octant. So you can find Octant into the bookmarks. So Octant is just our Kubernetes graphical interface, and you can see the same that I was seeing before. You can see the status of the containers that are now running. You can see, for example, logs for the containers, and you can also see the IP addresses where your application is going to be accessible. So this is also a very interesting tool, and it's worth it to checking it out in detail. But before we wrap this up, I would like to go a bit over the VM service. So when I was explaining before the namespaces, I was saying that these namespaces, you can think of these namespaces as a folder where a Tanzu Kubernetes cluster can be running, but developers can also deploy VMs by themselves, because most of the applications don't use just containers. They use containers, but sometimes they just need to connect into an external database that might be deployed inside a virtual machine, or they have some external dependency that is deployed as a virtual machine. So developers can also deploy the virtual machines themselves. And this brings a whole new world on virtual machine provisioning and managing inside vSphere, because now the developers will be able to provision and to self-provision the virtual machines inside these namespaces, inside the limits that a VI admin has defined for their project. So I believe this covers, this is a brief introduction to vSphere with Tanzu and to Module 3. There's a lot to it, and I definitely hope you'll have fun and you'll learn something new about vSphere and also about Kubernetes. So back to you, Peter.
Thanks very much, Jose. We'll just reshare our PowerPoint presentation. That wraps up our instructor guided lab and this particular section. I'd really like to thank you all for joining us, and I hope you enjoy the rest of VMworld 2021.